Okay, we're going to get ready for our quiz. We have a quiz tomorrow in 5.1, 5.2, and 5.3. So let's get started. The first thing you need to know is from 5.1, you need to have those terms memorized, the terms that classify a polynomial by its degree and by the number of terms that it has. So let's take a look at this first one. You're first going to get any like terms together, and in this case, this polynomial doesn't have any like terms. So we're just going to rewrite it so that it's in standard form. Standard form is going to be 2x cubed plus 3x squared minus 5x. So that would be our polynomial in standard form. All the exponents are in descending order. So by its degree, it's a third degree polynomial, we can classify it by its degree. And the name that it is, when you take something to the third power, you cube it. And so this is a cubic polynomial. And then this polynomial has 1, 2, 3 terms. And so we classify that as a trinomial. Tri means 3. All right, for the next one, standard form polynomials do not have parentheses in them. Excuse me. So we need to take that minus and distribute to this 2 terms in the second, in the binomial. So what we get is we have 4x squared plus 5x minus 2x minus 4x squared. And when we simplify this, our 4x squares will cancel out, leaving us with simply 3x. All right, let's look at the degree on this. The degree of this polynomial is simply 1 because it has an exponent of 1. And so this is a linear polynomial. If we were to graph y equals 3x, it would be a line. And then the number of terms, it only has 1 term. So it's a monomial. Mono means 1. All right, finally the last one. Take that 2x and distribute it so that you get 2x squared plus 8x. And then take the 3 and distribute that, 3x squared minus 3x. And so let's simplify our like terms. It looks like I have a 2x squared and a 3x squared. So that gives me 5x squared. And then I also have an 8x minus 3x. And 8x minus 3x would be 5x. Oops, let me use a different color. 5x. So that polynomial has degree 2. It's right here, degree 2. And then it's classified by its degree. We just studied these degree 2 polynomials. And the degree 2 polynomials are quadratics. And this polynomial has, it looks like 2 terms. And so if it has 2 terms, it's called a binomial. Bi means 2. All right, let's look at the next one. This one is going to be for numbers 4 through 7. So this polynomial here, this is going to be for all the rest of the page. All right, so the first thing we want to do is we want to completely factor into linear factors. Linear factors, everything's going to be to the power of 1 for our factors. And the first thing you want to do is you want to factor out a GCF. So in this case, all of my 3 terms here in this trinomial, they all share a 3 and an x. So we can factor a 3x out to the front. So I'm going to get x squared minus 2x minus 3. Now, I am not done. Those are not linear factors. I have a linear factor, it's 3x, but that's a quadratic factor that I need to get into linear factors. And I do that by doing star method. -3, -2, 1, and 1. 2 numbers that multiply to give us -3 and add up to -2 would be a -3 and a positive 1. That's x minus 3, x plus 1. So that is completely factored into linear factors. All right, now I'm going to sketch the graph on the axis provided. So I need to know what the zeros are because the zeros are going to be the x-intercepts of my function here. And so the zeros are found by finding the zeros of each factor. So I have 0, 3, and -1. So let's plot those over here. My x-intercepts are 0, 1, 2, 3, and -1. Okay, for the rest of it, you can use your calculator. Go to your calculator and plug in y equals x cubed. You can do one of two things. You can either plug in the original, or you can plug in your factored form. Personally, I suggest to plug in the original in case you factored it incorrectly. You can also plug them both in, one for y1, one for y2, and then you can check to see if you factored correctly, because there'll be only one graph that shows up. Okay, it's so early. All right, so go ahead and graph. And my graph, it goes like this. It goes up here, down, and then way down here and back up. It actually goes off my graph. So I can fix that by changing the window. I can go to window, and I need to change the y minimum. Because the y, bless you, the y minimum is not low enough. So go to window, press the window button, and arrow down to where it says y minimum, and plug in -20 for your y min. Okay, and then now hit graph, and it will show up, and there's the minimum. Okay. All right, so now we need to find the relative maximum. Oh, let me tell you that one more time because you might not have understood. So if you go to window on your calculator, where should I write this at? If you go to window, change the y min. Y min is at -10. Change it to -20, and then hit graph, and you'll see the whole thing. Rewind that if you need to. All right, find the relative maximum point. So here is the relative maximum point. It's right there. It's that maximum in that neighborhood. And so I'm going to go to my calculator, and I'm going to go to second trace, which is calc, and I'm going to calculate the maximum, which is number 4. Okay, so go to and press number 4, and then your calculator is going to ask you to go to the left side of the maximum. Well, here's your maximum right here. Here's the left side of it, and here's the right side of it. So you want to take your cursor and arrow it over anywhere on the left. I arrowed it and I put it somewhere right about here. Let me do it in red, it's a little bit better. And then I hit enter. Now it wants me to arrow back over to the right side. So I go over to the right side and I go somewhere around there with my cursor. And I hit enter. And then I hit enter one more time, and it will tell me that the maximum, the relative maximum, is -0.53, which is rounded 2 decimal places, 2.64. Hey, that looks pretty good on my graph. 2.64 is the highest that y value goes. Now we need to find the relative minimum. We're going to do the same thing. We're going to go to second trace, but we're going to find the minimum this time. So we want to go to number 3. And now we need to go to the left side of our maximum, or of our minimum. So here's our minimum down here, and I'm going to go over to the left, and I'm going to put my cursor just somewhere close over there, hit enter, and go to the right side. So now you're somewhere over here on the right, and you're going to hit enter, and enter one last time, and you will get that the minimum is 1.87, -18.19. There you go. Okay, let's go to the next. Here we go. All right, so the next one is, we're going to kind of go backwards now. It says, given the following zeros, write a polynomial in factored form. So instead of having a polynomial and factoring it and finding its zeros, I'm given the zeros and I need to go backwards. So the first thing you want to do is we have 3 zeros here. They're each going to get their own factor. So -1 the factor that goes with negative 1 is x plus 1. Negative 4 would be x plus 4, and 2 would be x minus 2. So that is factored form. Well, part B says now we need to get this into standard form. So that would be my answer for factored form, and I would just leave it. So to get this into standard form, though, I'm going to need to FOIL. So I'm going to FOIL the first two binomials here. I'm going to go x squared plus 4x plus x plus 4. So that I get x squared plus 5x plus 4. So there's my first two. And now I need to take this one and multiply it by the last one. So we're going to do a little something that I like to call superfoil. So superfoil is you take the first term and you distribute it to both these two terms. So you get x squared minus 2x. No, x cubed minus 2x squared. There we go. Then you take the 5x and do the same thing and distribute it. So when I take the 5x, I get 5x squared minus 10x. And then finally, I'm going to take that 4 and multiply that in and get 4x minus 8. Okay, so now I need to combine all my like terms. I'm going to go up here and write this in standard form. So I have x cubed. My like terms, I have a negative 2x squared and a positive 5x squared, which is 3x squared. And then I have negative 10x and 4x make negative 6x, and then minus 8. And there's my polynomial in standard form. I like to write y equals. All right. Number 9. List all the zeros of the polynomial and their multiplicities. Okay, so let's take a look over here. I've got 1, 2, 3. So from this first one right here, my 0 would be x equals 0. But because that x happens 3 times like that, I end up getting 0 3 times. So 0 has a multiplicity of 3. All right, let's look at x plus 2 next. X plus 2, the 0 I get from x plus 2 is negative 2. But x plus 2 is squared, so that happens twice. And so I end up getting negative 2 twice. So we say that has a multiplicity of 2. It's repeated twice. And then finally, from my last factor, I get x equals 4 is a 0. And that doesn't have any multiplicities, because remember, multiplicities are repeated zeros, and 4 does not repeat. It's just by itself. So those are your zeros. There are 6 of them. All right, so if you've been tuning me out so far, you don't want to on this one. This is one of the hardest ones. We're going to solve by factoring. And this is the difference of two perfect cubes, and these are tough. And just remember, the difference of two perfect cubes, if you have a cubed minus b cubed, then that will factor like this. It's going to be a minus in the middle and a plus over here. Take the cube root of a cubed, which is a, and you take the cube root of b, which is b. Then you take that first term a and you square it. Then you take the two of them together, a, b, and then you take b and you square it. Okay? So let me fix that. That looks like it's on the outside, but it should be on the inside. So b squared with a parenthesis. All right, so here we go. Let's go ahead. We're going to factor this into a binomial times a trinomial. And it's a minus in the middle, so it's going to be minus plus. Now, if it was plus, it would be over here. If this was a plus, it would be plus here, minus there. Okay? All right, so we take the cube root of 8, which is 2, and the cube root of x, which is x. The cube root of 27 is 3. You're going to take this 2x, and you're going to multiply it by itself, 2x times 2x, square it, and you're going to put it right there. For the middle term, you're going to take these two together. You're going to put that in the middle. So 2x times 3 is 6x. And then finally, for the last term, you're going to take negative 3 and square it, which is positive 9. All right, so for these, this binomial right here will always give you your one real answer. So you set it equal to 0, and you get that x is 3 halves. That's your one real answer. From this binomial here, 4x squared plus 6x plus 9, you're going to set that equal to 0 and solve. And unfortunately, it's not factorable. It will never be factorable. And you will always have to use your good old quadratic formula on this part. So x is equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So x equals negative 6 plus or minus the square root of negative 108 over 8. And you can do that on your calculator. You just go 36 minus 4 times 9, negative 108. And then negative 108 is divisible by negative 36, because we're looking for perfect squares here. It's negative 36 times 3. And so we take the square root of negative 36, and we get, kind of run out of room, x is equal to negative 6 plus or minus 6I rad 3 over 8. And then finally, I'm going to go over this way. Finally, just take the, or reduce everything, because negative 6, 6, and 8 are all reducible by 2. So x would equal, divide everybody by 2, negative 3 plus or minus 3I rad 3 all over 4. Those are your other two answers, so you get 3. And we should get 3 because it's a cubic function. All right, that's going to be the hardest one on the test or quiz tomorrow. If you're struggling with these and you still need extra help, please come in tomorrow in the morning. I hope I'm there. All right, part B now. Part B is a quartic. It's a 4th degree polynomial. And so we're going to treat these just like a regular old factoring problem. Just a regular old star. You put negative 50 up top with a 23 on the bottom and a 1 and a 1. But instead of x, we do x squared and x squared. Okay, so two numbers that multiply to give us negative 50 and add up to 23 would be a positive 25 and a negative 2. So plus 25 minus 2. All right, so what we get is we get our two factors here. We get x squared plus 25 equals 0, and x squared minus 2 equals 0. And we're just going to solve these by finding square roots, because there's no x term, it's just x squared. So we can simply, for all of these, subtract 25 over, and then take the plus and minus square root of negative 25, which would be 5i, plus and minus 5i. Over here, you're going to add 2, take the plus and minus square root of 2, which is just square root 2. So those are my four answers. I have 5i, negative 5i, rad 2, negative rad 2. You don't need to list them like that, but if you wanted to list them all out, you could. But that's 4 answers. Okay, and finally the last one, solved by graphing. All right, so you're going to need your graphing calculator. And what you want to do is you want to make sure that your polynomial is equal to 0. So if there's stuff on one side, bring it all over to the other side. And for this problem, we're going to, in our calculator, input y1 is that first side, the cubic polynomial, and y2 is 0. And what we're going to do is we're going to find the intersections. of this polynomial. Okay, so we have x to the third. So put this in your calculator. Plus 5x squared plus 3x minus 10. And then make sure that y2 has a 0 there. y2 is 0. And then graph. Okay, so my graph is interesting. When you solve by graphing, by the way, you are only finding the real answers. Okay, you're not going to find the imaginary answers on this graph. And so this graph, what it did was it went like this, and it wanted to touch the x-axis there, but it didn't, and it went like that. Okay, so that's y1, and then y2 is just simply the line y equals 0. And if you notice, these only intersect in one place. So there's only one real answer, and that's the only answer you have to find. Sometimes there will be more than one. Like if, for example, if I had a, if this cubic function went like that, I would have to find 1, 2, 3 answers. It makes it longer. But this one only has one real answer. So here we go. We're going to go second trace, which is calculate. Second trace, calculate number 5, the intersect. And then just hit enter 3 times because it's just going to bounce back and forth between the curves that you need. And there it is. X equals 1.06. Just rounded 2 decimal places. Okay, that's it. And that's the lesson on 5.3. The second part of 5.3 was graphing on your calculator. If you need more help with that, you can look in your book. They give some good examples, but you just graph it like we did quadratics, y1, y2, find the intersection. Tomorrow is the quiz. We will review before the quiz, and I'll answer any of your questions. But if you also want to come in tomorrow morning, there will be a study session at 7:40 a.m. All right, see you then.